share. Let me get to hear from a few of our members so that I can start the session officially at 8:20 p.m. So someone please feel free to share. Who will go first? Who is ready to go first? Anyone?
Hi, good evening.
Hello Rashid, how do you do?
I'm good. How are you? Good?
I'm also doing well.
Yeah, I'm good. The video was very informative, and I think I got a good idea of pre-stress and post-stress concrete. Hello.
Yes. Hello Rashid, we can hear you.
Yeah. So we got a good idea of pre-stress and post-stress concrete, and we
Yes,
understand the compression and tension,
yes,
and we are good to go with the new lecture, and
yes,
we are happy to have much information to create our models, and we fulfilled almost three submissions for the milestones. So
yes.
I'm waiting for the next. So that's the story.
Super. That's nice to hear, Rashid. It's nice to hear that you have been
Yeah,
able to submit all your milestones. But before you go, I have one simple question for you. I
yeah.
hope you've been to site before. Have you? Have you ever gone to site to check out Rebars or just do some
No,
supervision works?
no. I'm a draftsman, senior draftsman. So I know
Oh,
the technical things in the drawing. So I'm not visiting
uh,
sites.
okay. No worries. Thank you for sharing, Rashid.
Yeah. Thank you very much. Welcome.
Someone else, please don't feel shy. Someone else, please take on the mic.
Yes, engineer. How are you?
I'm doing well.
This
How are
is
you doing, Moses?
I'm great. This is Moses from Kenya. I also got a very good insight about the constitutioning and the pretensioning of
Yes.
of the concrete. It is a very good. It is a very good thing to share with us. And I think also as we proceed, maybe you can devolve into clarifying where is needed in the construction.
All right. Thank you so much, Moses, for sharing. Someone else, please feel free to share. Feel free to unmute and talk to us. Anyone? Anyone willing to share? Anyone willing to unmute? All right. So, since we're not going to stay in silence, I'm going to start the session officially. And we are going to start with one of the items that we did not get to do last time. So this is going to be the general flow of today's class. We are going to start with importing the IFC files that we shared with you via the learning resources. And then after importing the IFC file, we are going to see how our structural members interact with the architectural model. All right. So we'd like to know if we have columns going through windows, columns going through doors. How do our columns interact with the architectural walls? So we'd like to see that. So importing the FC file will enable us to see the architectural model from a different software, and you're going to be using that in today's class. Then we are going to create a few filters, and then you're going to go into Rebar modeling. All right, so I hope you will be able to follow, and also feel free to raise any questions if they come along in the course of the class. So you can drop them in the chat box, or I'll give you time to raise them as the session continues. So I'll share my screen. I'll share my screen. So if you can see my Revit software, please type a one. Let me know that it's visible. Please let me know that my software is visible. Okay, super. So this is what I want us to do. At the moment, we only have the structural model that we have all modeled, all right? So I can see some of us have already been able to create this section box. So I want us to do this thing, this simple thing. So I want you to be in a situation where you can visualize the entire structure in 3D. Okay. So if you had used the section box and you have been unable to go back into the entire 3D model, you can be able to be in the 3D view first, press escape to ensure you have not selected anything. And then in the properties tab under extents, there's this section box over here, and check it, and your 3D view will reset back to the defaults. All right, so this is what you're going to have. Then after you have this, now we can be able to link the FC file. So we said the FC file is an industry foundation class. It allows you to move information or transfer information from various softwares, and it's a standard class that can be opened in all BIM softwares. Okay, so it means you can move your data from Revit to another software uh, that is not made by Autodesk. You can move data from, say, ArchiCAD, Tekla, ETABS into Revit as well using the FC files. Okay, so this is how you link your FC file. I recommend you do this in the first floor or any other floor at the top of foundation. And this is because we do not have the top of foundation level in the IFC file that you're about to import. Okay, so I recommend you import the FC file while in any of these views from the first floor to probably the roof floor, but don't do it in the top of foundation because we don't have this level in the FC file and you might not be able to see the file while in this level. All right, so with that done, linking the file should be easy. All you need to do is go to Insert, as we did for the PDF and CAD files before, and then you click on IFC file, scroll to where you have your file stored. Scroll to where you have the file stored. If you don't know where the FC file is, just use the link from which you downloaded the PDF files and the CAD files. You should be able to find the FC file there. So go to where you have yours stored, click on the FC file and open it. So at the moment, leave everything as default and then give Revit a moment to load. All right, and then as you import this FC file, I want you to take note of one thing. It is going to make your model really heavy. So I recommend that you just link it, get to move it where we want to move it, and then once you are able to visualize your model, I want you to unlink it from your model. All right. So after you've opened it, you're going to notice that it has not been are placed on top of our floor plan as you would wish. Okay. So what I want you to do at this point is select the file itself. Remember, your software is going to be a bit heavy at this point, so just work slowly. Select the file itself. Ensure it has not been pinned. If it has been pinned, you're going to have the option to unpin it. But if it's not pinned, you can see you cannot unpin it, and this means you can move it. So move it. You can move it by this corner here and move it so that it flashes with this corner right there. Okay. And then once you have your FC file line on top of your floor plan, you can now go into the 3D view. Okay, it's you can now go into your 3D view and you can be able to see how the architectural members are interacting with your structural members. All right. So in this situation, if you do not want your walls going excessively outside the walls, you can be able to take note of that and be able to change the position of your wall so that you can have what you need. Okay. So you can see the areas where we have modeled our cantilever slabs or our balconies, and you can see they are where they should be. So this is what you can generally use. You can generally use an IFC file for. You can be able to confirm any errors before you proceed. So if you can go to an elevation view, get to take note of a few differences that you may be having in your architectural model and in your Revit model. So you must take note that the levels vary by a bit, but that is no cause for concern at this point. We changed the levels as we were doing our work, and that's good enough for us. But in the eventuality that your levels vary by by a big value, you can be able to take note of that error and be able to correct it even before you go on into further, before you go into doing more works here, so that you can save your energy and also time later on. All right, so you have this. This is how you do it, and I think it's pretty easy. So you can be able to model it and get to see how your members interact with the architectural elements. All right, so I'll close this project and then I'll open a project that I'm going to be using for today's demonstration. So just give me a moment as I close this and open a model that I'm going to use. Okay, I forgot to show you something. I forgot to show you how to unlink it. So I'm going to do that again so that you can be able to unlink it as you work on it. So we're going to re-import the IFC file in this model as well. We are going to go into the Insert tab, and then we are going to go to Link IFC, select the IFC, and click on Open. Then after you do that, give it a moment to load, and you'll have your FC file within your model. You can change the graphic display option to shaded or realistic so that you can have something that you can visualize better. Then select your IFC file and use move over here to move it. So I'm moving it by this corner and moving it to this corner here. Yeah, so that it fits perfectly there. Then after you do that, you can go to your 3D view and get to just have a view of how your members are interacting with the with the architectural members. Okay, so for example, you can see here this should be the opening into the parking lots. So if you had a column here, you can be able to tell that that system will not work for this particular design. All right, and then in the eventuality now that you have linked your file into Revit, and you now want to remove it so that you can proceed with other works, this is how you do it. You go to manage, okay? And then once you go to manage, you go to manage links. And once you are here, you can be able to see all the files that you have linked into your project. So you just select it, right click, and unload, okay? So I'll repeat that. In the eventuality now that you have had a good visual check to see how your structural members are interacting with the architectural members, you can be able to now unlink these IFC file. So what you do is you go to Manage tab, then you go to Manage Links, and then at this point, you go to the IFC file. This is what we are interested in. Right click and then unload. So click on OK, and you are good to go. Then also we do not need the CAD file as well at this point, so we can unlink it in the same way. So you just right click on it and then unload it. Okay, then after you have done, you just close and you'll notice that it now disappears from the model itself. Also, the CAD file that we had in our model, it has been removed from our model. Right, so that's how you are able to link that you are able to link files into your software, and that's also how you are able to unload any links or any linked files from the model you are working on if you do not need them in that case. Okay, so let's proceed. The next bit will be to create filters. Just a moment, someone is unmuted. Please ensure you're muted. Okay, so I now want us to create filters. And what filters are, they are able to control the visibility graphics. They enable us to control the items that we can see in Revit and what we cannot see. All right. They enable us to clearly visualize what we have in the structure itself so that we can be able to make better decisions by just looking at it. So at this point, by modeling this structure, we have different cross sections of columns. We know we have 4 cross sections, but by looking at it from afar, we cannot be able to tell where our column ones are, where our column twos are, where our columns three are, where our columns fours are. Okay, we are not able to do that. Okay, but it would be good practice as you look at your model, you are able to tell where a particular family is. Okay, so that if there was an error during modeling, you would not expect your column 4 or your column 2 to be here as per your design, you can be able to make those changes earlier on before you proceed with the other works. Okay, so this is how you create column. This is how you create filters. So to create filters, I'm going to take you back to the visibility settings that we have used before. So the visibility settings are one, settings that affect whether elements are visualized or if you cannot see them in Revit. Okay. Number two, they affect how elements are seen or visualized in Revit. So they affect the cut patterns, they affect the colors of the members themselves, and you're going to be able to see that. So I know for some of you, you've probably not cracked that at this point. Probably your staircase are not visible in the 3D view. And if that is the case, you can be able to make them visible by going to the visibility graphics. There are 2 ways of doing that. You could use the longer method where you go to the view tab and then you click on visibility graphics over there. And then the stairs being an architectural family, you click on this drop down and select architecture. Then after you do that, scroll down and look for stairs. So any item that is checked, it means you can be able to visualize it in this view. And any item that is unchecked, it means if you have it modeled, you cannot be able to see it. So if you model anything and you would like to visualize it in this view, you just go to visibility graphics and look for that particular family or element and ensure that this checkbox has been checked. Okay. Then after you have that, you're going to be able to, after you do that to your staircase, you should be able to visualize it. All right, so then there is the other thing. Now I want us to create the filters themselves, and you're going to create filters for each individual cross section of the column. This is to show you that you can create filters for each individual cross section, and then for the beams, you're going to create one filter for all the beams. But following the workflow that you're going to be using for the columns, you are going to at least have the knowledge that if the need arises where you would want to have a different filter for each cross section of a beam, you can be able to do that. So let's do this. I'm going to go to, I'm going to go to, I'm going to go to the structure over here. We're going to go to the visibility graphics, and we are going to create a filter. All right. So to create a filter, we open the visibility graphics settings and we go to filters over here. But I'm going to repeat how we got here just in case anyone is lost. Okay. So to remind you or to give you a recap, we say the visibility graphics are settings that one affect how elements are visualized in Revit, and number two, they affect whether elements are visible or not. Okay, I hope that is clear. They affect whether elements are visible or not, and they also affect how elements are visualized. Okay, so now that we understand that, we want to affect how members are one visualized and whether they are visualized or not. And we are going to do that by the use of filters. So we are going to go to the visibility graphics. We said you could go to the view and then click on visibility graphics over here, or you could just type VG. You could just type VG and the visibility graphics dial box will appear. Then our interest is now in creating a filter. So we are going to go to filters over here. And once you get to filters over here, we are going to create a new one. So how do you create a new one? This is how you create a new one. You go to edit stroke new at the bottom over here, left click on it. And then once you get this filters dial box, you get to this new icon over here. It looks like a page that is folded to the top right and has a sun icon to its top left. So you click on this and then you are prompted to name your filter. So we could call this column one. All right. And then we are going to click on OK. Then after you have named your filter, now you need to set the rules that affect how your filter works. So for you to understand what this filter is, you need to basically understand what the visibility graphics are. Okay, so we said the visibility graphics are settings that affect whether an element is visible or not, or fails, or it also affects how a member is visualized in terms of the color, the cut patterns, etc. So once you have your filter created, the column one here, you go to the filter list. So all members we are working with are structural members. So you can just check, you can uncheck architecture and ensure you are remaining with structure only. Then after you have that, just scroll down and look for the columns. So scroll down and look for structural columns. You have to look for structural columns. As you scroll up, there are going to be other columns. Please don't check these. Be on the lookout for these. Scroll down and ensure you select structural columns. Then after you do this, after you've selected the category that you want to create the filter from, you now go and set the rules. So these are the rules that are going to affect whether the element is visible and how it's going to be visualized. So number one, we want to we want to set that it must equal all rules must be true. Okay, and then if all rules must be true, we now set the condition. So what is the parameter that has to be that the software is checking? So for this one, we're going to be using the type name, and this is the name that you give to your column. It could be C1 200 by 450 mm. It could be column 1 200 by 450 mm. That name that you assign in the family you are created is what we call the the type name. So you're going to scroll down and look for type name. And then here we are going to set the operator. What does this type name have to be? How does the software reference this type name with regards to the filter? So for this one, it strictly has to be equals to. So the type name because we are creating a filter for column one only, the type name has to equal column one. Okay, so it has to equal column one here. Then you click on apply and okay. Then after you have created a new one, now you just need to add it. So you click on add, you select the filter over here, you click on OK, and you have your filter here. So you can see it is one enabled, and number two, this one affects the visibility. So we can now see it affects the visibility. If I was to uncheck this, all our column ones are going to disappear. You're going to see that you cannot be able to visualize. Okay. So number one, as we said, the visibility graphics affect whether an element is visible or not. So that is the part one of our filter. Then the second part, it affects how elements are visualized. So that is with regards to the color, the pattern, etc. But for now, we are going to focus on the pattern. So after you have your filter created, go to patterns, and then just under patterns, click on override. Go to pattern overrides. Now we're going to give it a pattern. We want to affect how this filter, or we want to set how this filter affects how the column ones are visualized. What is going to be their color, what is going to be their pattern. So I want you to click on this drop down. I want you to select a solid fill. And after you select solid fill, I want you to select a color. So I could go with blue for now, and then click on OK. Click on OK again, apply, and OK. And then from this view, you can be able to tell that all our column ones have been given a specific color. So if you are working on your model and you have color-coded elements, you can be able to tell which elements you are looking at. So if we had modeled a column one at an undesirable location, we can be able to tell that earlier on, even before we get to the next part. So I'm going to create filters for the other columns. So to create filters again, we go to visibility graphics, and then under visibility graphics, we go to filters. Then to create a new filter, you click on edit stroke new. Then you add the new filter here. You give it a name first. So this is going to be column 2. Then after you do that, now you have to select the category. So the column is under structural columns. It's a structural column. So check structural column, and then you get to set the rules. So we are using the type name, okay? We are using the type name. And then for this one, it has to be equals to, because it's a specific cross-section. And then at this point, you select the column 2 cross-section, C2, click on apply, and okay. Then you add it, column 2, you add it, and then you click on OK there. Then go to patterns, click on this override rectangle over here, change the foreground pattern to solid fill, and then enter color of your choice. So I'm not really great at colors, but I recommend you don't work with very bright colors just to make your model easier to look at. So I'm going to use a different color for column 2 and click on OK. And then by doing that, you can now easily tell, or you can easily differentiate the various columns in the model. All right. So I'm going to do the next one for the column 3 and column 4s. I'm going to be a bit faster on these two. So to create the filters for column 3 and column 4, I'm going to show you a new trick. So we are going to go to filters and then click on edit stroke new. At this point, you're not going to create a new one. Rather, we are going to copy one here. So we're going to go to one of the column filters we created, right click, and then duplicate it. Then after I duplicate it, just rename it. So we can call this column 3, okay? And then click on OK. Then we don't need to select the category since it's a duplicate. The category has already been selected from our previous selection. Okay, and then now go to the filter rules. We don't have to do a lot here. All we need to do is click on the drop down and select column 3. Click on apply and OK. Then add it, column 3. Okay, and you can change the pattern as we did earlier. So the pattern foreground should be solid fill, and the color, please select a color of your choice. I don't know what to go with. I just go with that. Then click on OK, apply, and OK. Then by doing that, you can be able to see that you can be able to tell where our column threes are. But the color I chose for column 2 and column 3 are really, really, they're not easily differentiable. So I'd recommend you go with colors that you can easily differentiate from each other. All right. So we continue visibility graphics, filters, edit stroke new. We are going to duplicate this one more, duplicate it. Let's rename this now. So we rename this to column 4. Column 4, click on OK. And then just change the value to column 4. Then click on apply and OK, and then add it. Then after you add it, you change the pattern. So you go to pattern, override, you change the pattern to solid fill, and then the color, you can change it to a color of your choice. So which one do I go with? I'm going to go with this. Click on OK, OK, apply, and OK. And by doing that, you can be able to see where your column fours are. And I think they are where I expect them to be. And the beauty of this is you can do this for all the members in this model. You can do it for the foundations, you can do it for the slabs, you can do it for the shear walls, you can do it for the foundation walls as well, and you can be able to do it for the stairs as well. So I'm going to show you to do two more, and then we are going to share videos to guide you on how to create the filters for the other members. So to create a filter, you go to visibility graphics, and then you click on filter. Now we are going to create a new filter for the slabs. So we are going to click on edit stroke new. Then we are going to add a new one here. So the filter here will be slabs. I just call it slabs and then click on OK. And then in the filter list, this time I have to select one. So ensure the filter list is under structure. But now for the slabs, you just select floors. There are no structural flaws in this section over here. So you use structural flaws. And then after you do that, you go to the filter rules. So it has already read the category you want. You can see these are the flaws. And then we are going to use the type name as well. We are going to use the type name as well. And then we are going to use equals to equals. And then we're going to select the type name. So I don't know what my friend used. Let me see. Okay, so probably who is this? Natalie, if you are in the meeting, which floor did you use for your ground floor? For your floors, if you are in the meeting, Natalie.
Hello.
Hello.
Uh, just a moment. Let me confirm.
Okay. So I think this poses a good challenge. If you are unsure about the names that you created or the type names that you used for your structural members, this is what you should do. Just click on apply, click on OK, click on OK again. Go and select one. Go and select one. Go and select one slab, and then get to see which type name you used. So if you select one over here, go to edit type. This is what you are calling the type name. Okay, so you can be able to see even errors that may arise. So for example, you can be able to see that uh, Natalie used the same slab from the ground floor to the roof level, which is not ideal. So what we can be able to do at this point is we can be able to just select this slab, go to edit type, duplicate it. Let's call it the 175 mm RC slab, and then click on OK. whoever that is, Oliver. Okay, so just change the thickness to 175, click on OK, and you are good to go. So I'll want to show you something here. So I'll just change a few. I'll just change a few over here, probably to that point. Then click on this properties tab and select the type name that I want. And then let Revit do the rest for me. Okay. Then I'll go to visibility graphics, and I'll go to filters, edit stroke new, and I'll select the slabs, go to filter rules, ensure first the categories is under floors. And then in the filter rules, we're going to use the type name as the parameter, equals as the operator. And then in the value, we are going to to select the type name that we just created. Click on apply and OK. Then add it. I want you to see how this would help you identify errors earlier on. So if you were to give this a color, so solid fill, let's give these a different color. So which color do I go with? I'll go with this. Click on OK, OK, apply and OK. That's too bright. Don't pick that color, please. So you can be able to tell that this floor is suspended, but it does not have the same type name with the other floors. So there must be an error here. So you can be able to just visually tell that there is a family that is not at the right place, or it is not where it's supposed to be. So this is why we work with filters, just to enable us to be able to have a visual look or visually understand our structure better. So I'm going to create the last one for the walls, and then I'm going to leave the rest for you to create, since they follow the same workflow. All right. So I'm going to go to filter. I want to create one for the walls. So I'm going to click on edit stroke new. I'm going to create a new one here. I'm going to call these the lift core walls. Okay. The lift core walls. And then under structure now, under categories, you have to scroll and look for structural walls. You are going to find that there are no structural walls, just as there were no structural floors. So you will just select walls. Okay, you scroll down and select walls. And then in the filter rules, remember in the parameter, we are using the type name. We are using the type name for now. And then here in the operator, we use equals. And then in the parameter here, or the value, we are supposed to use the lift core walls, or whatever name you gave yours. Okay, so I'm going to select the lift core walls, click on apply and OK. Then I'm going to add them, lift core walls, click on OK. Then in the patterns, override pattern, select the solid fill, and then under color, select a color of your choice. Then click on OK, apply and OK. And you can be able to see that filter has been added. Then the beauty of using different type names, that's why we were emphasizing on you having a different type name for every member. So in this case, if your foundation walls and your lift core walls have the same type name, if you do not change the type name initially, they are going to have the same, color. All right. And that might not serve you really, really well. All right, so that's how you create filters. And then this is what they allow you to do. If you have filters, you can single out one element. So if I'm only interested in seeing my column ones, I can uncheck everything here. I can uncheck everything here. And if I had a filter for every element, I can uncheck all the other elements. I can turn off their visibility, click on apply and OK. And I'd be able to see my column ones only. All right. If I wanted to do the same for the beams, you can be able to do the same. So I hope that was understood. I hope that was understood. If you got that concept, please type a one. Let me know we are together. Please type a one. Let me know we are together. Super. I can see most of us are flowing really, really well. So we are going to go back. So in the eventuality that you have turned uh, the visibility of some of the members on and you'd love to visualize them, you just go to visibility graphics again, filters, and you check these checkboxes. You just check them and click on apply and okay, and your members will reappear again. All right. So those are some of the things that we use to make our work easier in Revit, especially when you are working with or when you are working on larger projects with that might be a little bit complicated to work with when you are visualizing everything in one view. Okay. And then the beauty of this, it will also be applied to the rebars, especially when you get to modeling rebars for the slab. We are going to create filters for each layer, be it the bottom ones, be it the bottom twos, the bottom three, the top ones and the top twos, so that when we are doing our annotation, it becomes easier. We can work on one set of rebars first. Then once you are done with that, we can turn it off and then move our focus or shift our focus to the next set, ensuring that it's just easy. It's easy on our eyes to work on it. Okay. So with that, we are going to go to a new concept over here. And the new one we're going to be working on is modeling the rebars. But before I go there, I wanted to challenge you guys. I know at this point you have enough knowledge to model the parapet level. We just need a floor, the columns over this section to cover the staircase, the shear wall itself, and this other staircase. I know at this point you have the knowledge to do that. So I am hoping that you are going to take that as a challenge and model the parapet floor on your own. Okay. So we are going to go to a new concept. We are going to model, we are going to start working with reinforcement. But before we do that, I'd like to take your attention to something else over here. So we are going to start with referring to the Eurocode 1992, section 1.1. And what you're going to be reading here, uh, the most important thing that you're going to be reading here is about the spacing of the bars. We are not going to, at this point, focus on what the annotations should show. Once we get to annotation, we are going to be able to do that. Okay. So what I want us to do is, for one, just get to see the guidelines that are they specified for the spacing of bars in individual members. Okay. So number one, the spacing of bars shall be such that the concrete can be placed and compacted satisfactorily for the development of adequate bond. Okay, so this means once you get to pour your concrete on site, you can be able to compact it. The vibrator can go through the different layers of bars so that you can be able to develop the adequate bond between concrete and the rebars themselves. So sometimes you're going to find yourself having structures that have too many bars, and you're not able to meet the minimum spacing between the bars, which typically the minimum spacing between bars should be equal to your largest aggregate. So if your largest aggregate that you have in your design or in your design mix is 25 millimeters, so it means at any point when you are doing your design calculations, you should always ensure that the minimum distance between any two bars is 25 mm. Okay. Then if you do not meet that, again, design-wise, you'd have to come up with a different design, probably work with a higher class or even go for some novel solutions, probably even use self-compaction concrete, but that would be really, really expensive. So you have to kind of balance everything so that you have something that is a bit economical. Okay. Then we have the clear distance, horizontal and vertical, between individual bars or horizontal bars of parallel, which the clear distance, horizontal and vertical, between individual parallel bars or horizontal layers of parallel bars should be not less than the maximum K1 bar diameter or 20 millimeters, where DG is the maximum size of the aggregate. So you can see what we were just talking about. It has been clearly stated there. And then point number 3, where bars are positioned in separate horizontal layers, the bars in each layer should be located vertically above each other. Okay, so this is the instance in, for example, in a beam where you have both bottom ones and bottom twos lying on each other, and you have been told that there should be sufficient space between the resulting columns of bars to allow access for vibrators and good compaction of concrete. And then lapping bars may be allowed to touch one another within the lap length. Okay, and the lap length is usually 50 times the diameter of the bar. Okay, and then the other important thing that we have to look at the is the bending diameter. So we are going to be bending our bars. So if I look at the standards of detailing, this typical cross section over here, we have this bend over here. So this bend over here, the diameter of the bend over here, is what they are referring to as the mandrel diameter, Okay, so there is a minimum diameter that you have to use. These are not things that you're going to definitely measure on site, but it's good for you to take notes so that you ensure you do not degrade your rebar while doing the cutting as well as the bending on site. So for any bar diameter that is less than 16 mm, you have to ensure that the minimum mandrel diameter for the bend is 4 times the diameter of the bar. And if the diameter is greater than 16 mm, it means that diameter over here, this diameter over here, should be greater than 7 times the diameter. But again, this is not something that you would really take keen of, really take keen or be keen with it on site, because it's relatively easy. It's relatively easy to achieve. Okay, so that should not worry you. Should not only worry you at all. And then the other one is with regards to the length of the hook. We are going to be creating hooks for our bars. And you can see at this point, for the 90-degree hook that we're going to be using for our foundations, we are told that this length above the mandrel should be at least 5 times the diameter of the bar. Okay, should be greater than or equal to 5 times the diameter of the bar. So if you are using a 12 mm bar diameter, it means this length over here should be at least 60 mm going upwards. So if you are catering for this length as well, so it means it would have to be relatively greater than 60 just to be safe. Okay, so we are going to use that information. At least we have a background, and we are going to start modeling the rebar. So we are going to start modeling the rebar with modeling the rebars for the foundations, just to uh, just to just to start off, because this is going to offer a softer launching pad, and then as the course continues, you're going to definitely continue to more complex members to model rebar for. All right. So to model rebar for the bars, we are going to be working in the top of foundation. And at this point, you are going to start with the easiest one. We are going to start with a small footing here, footing 1, and then you're going to proceed to the other footings, and then you're going to do one of the combined footings together, and we're going to provide you with recordings to do the other one for your practice, okay, or as part of the milestone. So when it comes to modeling rebars in Revit, you have to work in a section view, okay? So you cannot model rebar for any element in these plan views. You have to be working in a section view. And then we always recommend you create a section view for each element. so that you can be able to transfer those section views to paper space easily. So you're not going to be doing any drafting later. These are the details that we are going to export into the paper space later on. All right. So we are going to start with the foundations. So to create a section view for the foundations, you just go to the view tab, you select section, and then once you select section, just click on this drop down, select the cross section over here, click on edit type, duplicate it. Always ensure you duplicate it first, and then create a section for the foundations. All right. Then after you create a section for the foundations, just click on OK, and you can place your section over here. Just place it across the foundation, and then minimize the depth so that you can only see what is necessary. All right. Sorry, please let me turn this off. Okay, sorry for that. So we are going to proceed to model the Rebar here. So at this point, if you go to the views, you can be able to see the sections that we created for our foundations. You can also see the section for our stairs, and this is how it makes it easy for you, or this is how it makes your project browser a bit orderly. So if you wanted a section that pertains to the foundations, you definitely know where to get them. Okay, so we are interested in the section we just created. So we are going to expand the foundation sections, and then we are going to right click on it and rename it. So we want to be very sure. We don't want to be confused. So just click on rename. What's happening here? You just go to rename, and then uh, you rename it after the family you are modeling Rebar for. So this is going to be footing 1. You just name it as it is, and you're good to go. So whenever you're going through your project browser, you already know which this section belongs to. Then after you've renamed it, just left click twice to open it. Please ensure you are muted. Please ensure you are muted. All right, so at this point, we are going to now model the Rebar here. But before we do that, we need to ensure that this view is a bit presentable and that it's easier to work with. Okay, so one of the ways in which we can do that is working with a scale. So we are going to work with a larger scale because this is a smaller section. So we're going to change the scale to a 1:50. And then after we do that, I want you to select this grid here and this one. We do not need them at this point. We do not need them at this point, so we can hide them. And then after you do that, we would like to show I would like to show that these elements over here are continuous. All right. So for the ground floor slab, you'd want to show that it is continuous and that it does not end at this point. So what we usually use is component nodes as a break line. We usually use a component node known as a break line. And this is how you get to insert that component. You go into the annotate tab. Okay. You insert the component, you go into the annotate tab, you click on components, and then you load the family. Then after you click on load family, just click on this drop down, go back to libraries, click on English, select UK, then scroll down and look for annotations or detail items. Look for detail items, okay? Look for detail items and then left click twice to open it. And then left click on annotations and select the detail items break line. Then after you have this, just click on open and it has been loaded into your project. So at this point, you can be able to place it and extend it upwards just to show that this column section over here continues upwards. Then we can add another one here. So let's add another one here and show you hide the street footings as well. Don't delete anything. Something that I cannot overemphasize on is that you should not delete anything haphazardly in Revit. Just hide it in case you don't, in case you aren't sure if you need it in other views. Okay, so because if you delete anything in this view, it is going to be applied throughout the entire structure. So let me hide this grid as well. You just select it, right click, and then hide in view. So we want to break this slab as well. So what we do is we are going to go to annotate and then components. Because I've already loaded it, it is going to appear here. So you don't need to load it again. But for the purposes of reinforcing what we just did, I'm going to load it again. So once you get to annotate, then you select components, you go to load family, you click on this drop down, scroll back to English, you select UK, then you scroll down and look for detail items. Then after you open detail items, you select annotations and you select the detail items break line. You click on open and you place it here. So at this point it is horizontal and you might want to change its orientation. So we change its orientation using the space tab. So if you'd like to change how it's been oriented, you just click on the space tab and Revit will reorient it. Then you place it. Okay, then you're going to realize sometimes it is placed viewing the wrong direction. So at this point, we would want it to go outwards, not inwards. All right, so you just select it. We have this flip instance over here. Select it, then left click on this flip instance, and you're going to have it there. Then you can move it. You can move it inwards a little bit, and you are good to go. Okay, so this is how you do it, and then there are more edits you can make to it. You can extend it if you want, or move it, uh, or just move it if you are not pleased with where it has been placed. All right, so that's how you do it, and then also ensure you hide these walls. Okay, so that's how you do it, and then just bring these, click on this rectangle over here and bring it downwards, so that you have a section that you are going to use now for our details. So you're not going to be making other details. This is what you're going to transfer to the paper space. As we said earlier, we are not going to be doing any annotation. We are going to be modeling the members in 3D, and that's what you're going to transfer into the paper space. All right. Then now, after we have this, we can be able to model our rebar, since this is a bit clean. Okay, so what you're going to do to model rebar, you go to the structural tab, and then you're going to be working in the reinforcement panel over here. So the first thing that you're going to do before you place any rebar is you're going to provide cover for that particular element. So we're going to provide cover over here. You left click, and then you select the family you want to provide cover for. So you select the footing, and then after you select the footing, you click on these three dots so that you can create a cover that you want. So you can use these pre-existing covers, but since we would like to add our own new cover, you just click on add, and then at this point you go to the rebar cover that has been added. You can call these foundations. You can call these foundations. And then for the foundations, you're going to use a thickness of 50 mm. So you just enter 50, click on OK, and then select your footing, click on this drop down, scroll up, and select foundations there. And your cover has been modeled in Revit. So what that cover does is that Revit understands that you're providing a clear cover for your foundation. That is, you're providing a specific thickness of concrete that you do not want your rebar to go beyond. So as you model your rebar, it ensures that your rebar is modeled constrained by that cover. So after you have your cover modeled, now you can model rebar. So to model rebar, you just click on escape, go to the reinforcement panel over here, and left click on rebar. you're going to get this warning. Just click on OK and proceed. So after you go into Rebar modeling, you're going to notice that the contextual ribbon changes. You're going to have a new pop-up to your right. It's called the Rebar shape browser. Just a minute. The new pop-up on your right is called the Rebar shape browser, and it shows you that are the various shapes of reinforcement families already in Revit. Okay, so it shows you all the families that are in your Revit templates. All right, and then if yours does not pop up, all you need to do is click on these three dots, and it's going to pop up. And then, and in the contextual ribbon, we have the various placement methods. So we can model expand to host by 2 points, freeform or sketch. So you're going to use expand to host most of the time. Then you're going to use by 2 points when you are going to be modeling rebars for the shear walls. And you're going to use freeform. You can use freeform for complex geometries, but for now you're not going to use freeform. And then sketch, you can create sketch when you have a very unique shape for your rebars. And then we have the placement planes. You're going to stick with the current work plane. So you're not going to be making edits to this. But for the placement orientation, you are going to be making changes to this so that it can affect how our rebars are being modeled with regards to the section you are viewing. Do you want your rebar to be modeled parallel to the work plane, or across or perpendicular to the work plane? So you're going to get to see how that works. And then you're also going to notice that the properties panel changes, and it now contains constraints that pertains to rebar modeling. All right, so let's start. Let's get started with rebar modeling. So once you go to rebar modeling, the first thing that you're going to do is go into the Rebar shape browser and select the shape that is suitable for the element that you're modeling Rebar for. So since this is a foundation, we are going to have a straight line over here and then hooks on the left and the right. So shape number 21 is the most suitable at this point. So you select shape number 21. And then after select shape number 21, don't model it yet. Go to the properties and we can make more changes here. So we can, in the properties tab, you can change the diameter of the bar. You can change it to any of these. So you can change it from a 6 millimeter bar diameter to a 50 millimeter bar diameter. But what I want you to note here is that we only have one denotation of the bar. We only have the H denotation. But since but these may not suit all of us because of what we have in the market. So for some of us may prefer to use the T12, some may prefer to use the D12. Some, especially those in the southern part of the continent, might also prefer to use the Y12. Okay, so if you want to have changed the different or to have a different annotation, what you have to do is to ensure that number one, you select that shape. Okay, you select that diameter of the bar. So the number here represents the diameter. So I want to create a T12. I'll select the H12. I'll go to edit type. And at this point, I'm not going to change anything. I'm only going to duplicate it and rename it. Okay, all you need to do is duplicate it and rename it. Then click on OK, and you're good to go. Now you have your T12 bar. And then in the properties, you have to partition. So the partition is really important when it comes to scheduling. Okay, you have to partition your bars as you model. So what the partition does is, as you create your schedules, the software is able to tell that this particular rebar or this particular rebar set is housed or it was modeled in the foundations. Okay, so you can be able to create a schedule that is able to communicate that this number of bars, this shape of bars these quantity of bars are located in the foundations, in the slabs, etc. So the partition refers to the family hosting the rebar itself. So for this one, you are going to enter foundations or footings, whatever works for you. So foundations, and then you're going to scroll down to rebar set. So the layout rule affects the number of bars modeled. So for the layout rule, I would want us to use maximum spacing. We want the Revit to be able to count the number of bars for us. So I'm going to change the layout rule to maximum spacing and change the spacing to 200 mm. All right. And then after you do that, you just go to comments. And then the comments are the information you give the software to tell, just to give it more information, to tell where your bar is located with regards to the other bars, which is the bottom one bar, which is the bottom two bar, which is the top one bar, and which is the top two bar. So for this one, you're going to start with the bottom one bar and click on apply. So the bottom one bar refers to the first bar that you are going to encounter as you approach this particular family or this particular this particular foundation from the bottom. So the first bar that you encounter is your bottom one bar. And then after you have it, after you have it modeled, just press on escape and you have your bar here. All right. Then after you have your bar here, now you can model the bottom two bars that are going to be running across this section. So before we do that, I would want us to change the hook length. So to change the hook length, all you need to do is select the bar itself and then click on this dimension over here. Remember, we said the minimum should be 5 times the diameter of the bar. So we can enter 150 because we know that is sufficient enough. So select this and then enter 150 over here. And that will be sufficient for this particular footing. And then after you do that, now we need to model the bottom two bars that are going to be running across these across this section. So to do that, we are going to go to rebar again. Okay. And then you're going to select the same shape, number 50, number 21. And then this time we are going to select placement orientation perpendicular to cover. So whenever you want to model bars that are going to be running across the view you are in, so you want them to run across this bottom one bar, you select perpendicular to cover. But if you want them to go in the same direction as your view, like this one horizontally, this view, you use parallel to work with. So we switch to perpendicular to cover. And then you ensure the diameter is correct, T12. The partition is foundations. Layout rule is maximum spacing. When the spacing is correct is 200 mm. And then for the comments, now you enter bottom two so that it communicates correctly. And then you just place your rebar there and press escape. Then after you model it, just select them, select the set you just modeled and move them upwards so that they are above the other rebar. And then with the bars still selected, go into the properties tab, change the A length, change this length to 150 as you did for the other one, and also change this C 150 just as you did the other one. So that is just to show you that you can make the change here using this parameter here, or you can make the change in the properties as well. So you can see A and C here. So we just edited those values for these bars here because we cannot be able to access those legs in this view. So we just select them and change their properties from the properties panel. And that's how you model your bars. And then Revit is able to count for you the number of bars that you need. All right, so that's how easy it is to model rebars for a particular member. Now I want to show you something really cool. So what I want you to do is you might want to see this in 3D. You might want to see this in 3D. You can use the method we have been using. So you can select the footing. You can select the footing and go to the 3D view, and you can be able to see your bars there. Okay, we can change this to realistic, and you can be able to see your bars there. Okay, that's one way you can do it. Then the other way you can do it is you can create a specific 3D view for this section that you just modeled Rebar from. So you can go to the project browser, right click on 3D and duplicate the view. So duplicate it with detailing and rename it. So we can rename this to footing one. You don't need to do this for all the footings. This is just to show you that you can do this, so that in the eventuality or in case you need to view a certain element, you can be able to do it. And then after you do that, I want you to come to this icon here. And as you move your cursor along this, you're going to have this arrow here that stands for the context menu. You have to be in the 3D view that you duplicated, then move your cursor along this menu, left click, and then scroll down to orient. So you can orient this 3D view to a view, to a direction, or to a plane. So we are interested in a view. So you place your cursor on orient to view, scroll down to sections, and then select footing section one. Okay, and by doing that, you have your footing selected. So you can hide the members that you don't want to see. Just select them and hide them in view by elements. And then I just select this. You have these grids, extend it, extend this to the other part as well. Okay, hide this. Again, you don't have to do this. This is just a demonstration of what you can do. And then you're going to proceed. So I'm going to select the rebars over here. I'm going to select this footing and just hide it in view for now. And you can be able to see your rebars there. So you can be able to see that Revit was able to model all the rebars for you. So I wanted you to see that in 3D. Okay, so I'll go back to modeling so that you can be able to get a better understanding of it. All right, so we have modeled one, we have modeled one, we have modeled one, we've modeled Rebar for one footing over here. So we are going to go to the next one, and then you're going to do two more, one for this one, and then the other one for these combined footings. So we are going to go to this footing over here. We are going to go to view, as we did, section. And then at this point, don't create a new section. Just use the foundation sections you created earlier. Use the one you created earlier, and then place your section across it. And then bring this closer or reduce its depth and click outside. Then if you go to your project browser, and as under the foundation sections, you can see all your sections coming over here. So just select it, right click, and rename it. So rename this to footing one, footing two now. Rename this to footing two, and you're good to go. So this is the importance of naming them as you go. It ensures your drawing or your model remains clear. Okay, it's important for you to ensure your model is very clear so that when it comes to plan and production, you are not confused or it doesn't become unnecessarily tasking for you. If they are named correctly, you can be able to know which section I've printed, which one I haven't. Okay. So after you have this, after you've named it, just left click on it twice to model the rib or to open it. Then after you do this, change the scale to 1:50 or something friendlier, and then do the necessary. So the first thing that you're always going to do is to clean it up. So you can select these grids, they are not necessary, and hide them in view. Okay. Then after you do that, please ensure you hide the wall as well. It tends to get forgotten. Ensure you hide it. So select the wall over here, right click and hide it in view. Hide the street footing as well, hide it in view, and hide the wall as well. So just place, if there's a wall, if there's a column you don't want to, if there's a wall here, just hide it in view so that your detail is a bit clearer to see. Okay. Then after you have that, please provide the annotation, the break line to show that these members are continuous. It's just that you are not showing the entire member over here. So to provide the break line, what you do is you go to annotate, you go to components, and then if you are ready to load it, you just go to load family, you click on this drop down, you scroll to English, UK, you scroll to detail items. And then once you are at detail items, you open annotations and you select the break line over here. Click on open. And now all that remains is placing it. So place it and then use these grids to ensure that it covers your member well, or it hides the unnecessary items. Then extend it upwards. Okay. Then after you do that, now place it on the slab as well. This slab is continuous and would want to break it at this point. So we said if you can change the orientation, you can change the orientation of this break line by clicking on the space bar. So change the orientation and place it there. And then after it has been placed, you can select it, just make a few edits to it so that it appears as you want it to appear. And I think that is good enough. Then after you have that, select this section view, this boundary, then use this circular grid to just bring it down so that you are remaining the section that you want to view. So you only want to view the section view. You only want to view the section view. So I'm going to bring it to that point and this one to that point, and you are good to go. All right. Then after you've placed your break line on both the columns, the beams, or the slab, now the next part is to ensure that the section view only shows you the detail that you want. And then after you have that, provide cover. Please don't forget to provide cover. So you go to structure, cover, and you click on the foundation. Then after you do this, since you had already created the cover before, we don't need to create it again. So you just select your footing, then click on this drop down and select the foundation's cover you created earlier. And then after you do that, you are good to go. Just click on escape. Then you go to Rebar. And then we said the first thing that you're always going to do is select the shape that you need. So for the footing, we are using shape number 21. And then you're going to start with modeling the rebar. So the bottom one is going to be parallel to this work plane. It's going to be going uh, horizontally. So let's equate horizontal to parallel to work plane and the dots to perpendicular to cover. Okay, just to make it easy, let's equate the horizontal bars to parallel to work plane in this view. And then the dots are going to be perpendicular to cover in this view. So we want the horizontal bars here. So you click on parallel to work plane and then ensure the properties are right. So we are using the T12 at this point. The partition is foundations. The rebar set affects the number of bars that are modeled. So we are not interested in telling Revit the number of bars we need. We only need to tell Revit that we have a maximum spacing of 200 mm, and it's going to do the calculation automatically for us. So let's have a lateral of lateral maximum spacing, and the spacing is 200 mm. And then for the comments, let's have bottom one. Let's have bottom one, and then place your rebar there. And then after you do that, you can just click on escape, select it first. Please ensure you always if you're not sure about the comments, just select the rebar again and ensure the comments are visible. Then change this a value. So let's use 150 for this one as well, and 150 for this one as well. And we are good to go. Now let's model the other bars as well, the bottom twos. So to model the bottom twos, you go to Rebar. Since they are dots, we said we are equating the dots to perpendicular to cover. So select perpendicular to cover. You ensure that the bar size is 12 millimeter for this particular footing. And then the partition is foundations. The lateral is maximum spacing, and the spacing is 200 mm. And then for the comments, please now change this to bottom two. Change this to bottom two and click on apply. And then after you do that, just place your bars and you're good to go. Then select these bars and move them upwards. Okay. Up, ensure they lie on top of the other bar. And with these bottom two selected, with these bottom two bars highlighted, go to the properties bar panel, change the A value to 150 as we did for the other bar, and the C value to 150 as we did for the other bar. Then click on apply and you're good to go. So that's how easy it is to model rebars for these footing. So I am going to go to the next footing where we have both bottom bars and top bars for the footing itself. All right. So let's do that. I'm going to close this section at this point, and then I'm going to click on view section. Sorry, before I go on, I'd like someone to unmute and just tell me the general order or flow we are using to model the rebars. Someone, just anyone. Anyone willing to give us the general flow? We create a section view. Please go. Anyone? Ahmed, do you want to communicate with us?
Yes, Engineer Gatim. Good evening
Yes.
to you. I
Hello.
think when we begin by creating the section view, then we remove the details that we don't want. Then we go ahead to set up the cover. And after setting up the cover, then we choose the bar that we want. For that case, it was number 21. Then we begin by the bottom one. Either way, you can begin bottom one or bottom two.
Yeah.
Yeah.
Super. And also don't forget to enter the comments, the partition, and to set the maximum or to set the rebar set as well. Okay, so thank you, engineer, for that. I'll proceed to footing number 3, and then I'll show you something cool before we go to modeling the rebars for one of the combined footings. All right, so just as the engineer stated, we start with creating a section. And we said that if you've already created a family or a type name for this section over here, you don't need to redo it. Okay, you don't need to create another section for the stairs. So what this does is that it ensures that all your footing sections are under one panel, okay, or are under one general category called section foundations. You don't want to end up having stairs in different views or footings in different sections. It's going to make your work just unnecessarily, how do I say this? Unnecessarily tedious later on, okay? So this is the footing we want to model rebar for. So at this point, I'm just going to place a view across it, and then I'll minimize the view. Then I'll go to view. As the engineer said, the first thing that you're going to do is make this clean. So we start with the scale. And then after you do that, select the grids that you don't want to visualize and hide them in view. Okay. And then for the walls, these other foundations that are not necessary in this view, just select them and hide them in view. So be patient with this. Hide the walls as well. Always ensure you hide the walls. They tend to get forgotten. But just select them and hide them in view. Then after you have hidden them in view, you can expand these a little bit. And then after you do this, now you use the break line. So at this point, I'm not going to load it again. You only need to load it once. Then after you load it once, you just click on component over here and it's going to be there. Okay, I hope that was clear. You don't need to keep on reloading it. Okay, so you just load it once and it's going to be there for your use. And then ensure it has been placed correctly. Then click on component again. For the slab, we said you use the space button to orient it properly and then expand it. And then if you want to flip it, we have the flip symbols over here. So you can always flip it. Okay. And then after you have that, select this rectangle or viewport, just select it and ensure it now only focuses on this part over here. And then after you have this, the next thing that you should do is now model the rebar. But before you model the rebar, you have to provide cover for this footing. So you go to structure, you start with cover. We had created the cover before. So once you click on cover, just select your foundation, click on this drop down and select the foundation itself. All right. Then with that done, now go to rebar. For the footing, we said we are using rebar shape number 21. Okay. And then since this is a horizontal bar, the bottom one bar, we are going to use parallel to work with. And then at this point, I'd like to use the T16 bar. So to use the T16 bar, we are going to click on this drop down. And we said we are not interested in changing the diameter or the value of the diameter. We are only interested in changing the type name. So what you do, if you want a T16, if you want a D16, if you want a Y16, what you do is you go to H16, okay? You go to H16 or you go to the diameter that corresponds to the type name you want. So if you want a E20 or a D20, you're going to start with H20, then edit type and rename it. So at this point, we want a T16. So you're going to click on edit type, then duplicate this type and change this to T16. Click on OK, click on OK again, and you are good to go. You can see your T16 here. Ensure the partition is foundations. And then the rebar set is set at maximum spacing, and the spacing is 200 mm. And then for the comments, I change this to bottom one. We have it there and click on apply. Then after that, all you need to do is click on your footing and you're good to go. So at this point, I'll just select this. I'll change this to 200. And then I'll also change this side to 200. And you are good to go. Then after you do that, you can create the bottom two bars now. So you go back to rebar, you select shape number 21. This time, since we want it to run across this bar or perpendicular to this bar, we select perpendicular to cover. And then after you do that, ensure the comments are under bottom two and you place them there. Then after you do that, just select them and place them at that top there. And then with the bars selected, go to properties, change the A to match what you had for the bottom one bar, and then the C to match the same. And that's all you need to do. And now at this point, you have modeled the bottom one and the bottom two bars. And that is easy. That's all you need to do. So to create the top one bars and the top two bars, what you need to do is really easy. Select these two bars, select them, and mirror them. So use the mirror draw axis. So click on mirror draw axis over here, left click on this symbol over here, then scroll down until where you get these rectangular icon, okay? Triangular icon. So it shows you the midpoint of that footing, and then you can left click and draw your line there. Or if you are having trouble in finding this triangular icon, you can just type MP for midpoint, type MP for midpoint, and then left click and draw a short horizontal line. And you have and you're going to have your top one bars modeled. Then after you have them mirrored, select the topmost bar, scroll down and change the comments to top one. So you type top one and click on apply. And you're good to go. Then select the second top bar, select it, go to identity data, change the comments to top 2, and you are good to go. So that's how easy it is to do at this point. Okay, so that's how easy it is to do. That's how easy it is to do. And then please ensure you rename it before we forget. Always ensure you rename it. So this is going to be footing number 3. All right, so we have that. So I was to show you something cool before we proceed to modeling the rebar for the other for the combined footing over here. So in this case, someone may be wondering, do you need to model the rebars for all the footings over here? Well, you do not need to do that. So Revit is a really smart software. You can be able to propagate rebar from one element to the other one, provided they have the same cross section. So remember, it's expanding to host. And for that to work correctly, all you need to do is model rebar for one section. So this footing 1 here, the small one, then you only need to model it once, and then you can propagate this rebar to the other smaller footings. Okay, so you can select one rebar over here. Okay, so you just zoom in, select one of the rebars is going to be selected, left click, then right click, select all rebar in hosts. It's going to select all the rebar in this particular host here. Then go to propagate rebar in the contextual ribbon, and then just align by face. So you select this face over here, and then you proceed to select the footings with similar cross sections. Okay, you proceed to click on the faces of the footings with similar cross sections. Okay, so you can only do this for elements with the same cross sections. Well, you can be able to do it for elements with the different cross sections, but it's not going to work perfectly. Okay, so to avoid errors, just do this for footings with the same cross section. And then after you have that, after you've selected the members you need, just click on finish and you're good to go. And if you go to now these other footings, you can see the rebars have been modeled. Okay, so just to repeat that, we want to propagate the rebar in this particular footing. So all you need to do is left click on one of the rebars here, then right click and select all rebar in host. It's going to select all the rebar in this particular host. Then you go to propagate rebar. For now, work with align by face. So left click on align by face. And then after you do that, you're going to be prompted to select the face. So select the face of the footing that you are copying a rebar from. You select this face. And then after you do that, select the faces of the footing tools, and you are good to go. Okay, so that's how easy it is to do. And then for the footings trees, you can do the same, but there's no need of me repeating that at this point. So this is what I want you to do. I hope you are grasping the most important thing at this point is for you to grasp the concept, how to do it, and then you're going to follow the shorter videos that you're going to provide you with to do the others. All right. So I'll do this combined footing, and then you're going to proceed and do these others with the help of the shorter videos. All right. So this is what I want you to do. At this point, you want to model a rebar for these footing over here. But there's a catch here. Okay, there is a catch when it comes to modeling rebar for such an element. So all the rebars that we have modeled before, they were for square footings. Okay, so it did not matter if we observed the shorter direction or the longer direction. Okay, but in design, the shorter span and the longer span have an effect on how moments are distributed. And if it has an effect on how moments are distributed, it also has an effect on how the bars should be laid and how the detail or how the particular element should be detailed. Okay, so the rule of a thumb is to always ensure that your main bars are parallel to your shorter direction. Okay, the rule of the thumb is to always ensure your main bars are parallel or they run parallel to the shorter dimension. So if you look at this combined footing, it means that the main reinforcement should be parallel to this shorter direction over here. So this being the shorter direction, it means that the main bars should run in this direction. All right. And now we are going to model the bars with that in sight, okay, with that in mind. So if we want to model the bars, if we want to model the bottom one bars at this section, what you are going to do is you are going to go to view, section, and then we are going to create our first section running along the short direction, okay? So we are running along the short direction, okay? So after you have that, now go to sections, rename this so we can, I know according to the details we shared with you, this should be combined footing, a combined footing two, okay? And then just click outside and then left click press on it to open it. All right, and then after you do that, yeah, there was an error, sorry, there is no error. There is no error, sorry for that. So what I should do is I should move this one backwards and so that I can have a column in my view, okay? So always ensure that there is a column so that your detail makes sense. So just go to your top of foundation, and if you move these about, it affects how much detail can be seen. So in this particular section over here, our detail will not have column. But if I was to move this one backwards, it is going to have the detail of this particular column visualized there. And then I'm going to change the scale to something friendlier, 1:50. And then we are going to start with cleaning it up as we have done before. So what you are going to do is you are going to hide the unnecessary items. So I can select the walls, right click, and then hide them in view. Please remember we are not deleting anything. We are not deleting anything. Okay, I cannot overemphasize that. We are not deleting anything. We are just hiding them in view. So select these items here and the walls and hide them in view. So hide them in view by elements. Also hide his strip footing in view by elements. Hide this wall as well by elements and you are good to go. Now, after you have that, the next thing to do should be to use the components. So you go to annotate component. You don't need to load it again. Once you load it once, you are good to go. So you just place it there and you click on it to make edits to it or ensure it fits accordingly. Okay. Then you go back, annotate components. You just place one, click on escape, select it, and ensure it is placed appropriately. Then you can select it, use the mirror pick axis and mirror it by the center of the column, and you're good to go. So you have that. So after you have that, now use these rectangular sections over here to ensure you only have the details that you need. So I'll hide this as well, and you're good to go. So after you do that, we are going to go to structure. You're going to start with cover. Just click on cover, then you click on your footing, then you click on this drop down and select the foundations cover. Then just press escape and you're good to go. So you go to Rebar again. So change the this is the short direction, and the main reinforcement has to be along this direction. It has to be in line with this direction. So you change this to parallel to work plane, select shape number 21, properties T16, partition, foundations, rebar set, maximum spacing, and then the comments bottom one. Then just click on your footing and it has been modeled there. Okay, then change these. For this one, we can use 350. And then we are good to go. Then change the same in this direction over here. I change to 350 as well. And you are good to go. Then now let's model the bottom two bars. I hope it's now easier for you to follow. You just go perpendicular to cover, select shape number 21. Properties is T16, and then the partition is foundations, and the comments are now bottom two. All right, and then after you do that, just click and model them there. All right, and then after you do this, just select these bars and move them upwards, okay, to have them placed appropriately. And then once they are there, select them, go to the properties tab, change the A value to what you did for the bottom ones. Do the same thing and do the same thing for C as well. Then apply and you are good to go. Then instead of modeling this manually for the top bars, just select them, select both sets, use the mirror peak axis or mirror draw axis, use the mirror draw axis. And then once you click on mirror draw axis, move your cursor along this edge of the footing until you get this triangular icon over here, which represents the midpoint. Once you have it, left click on it and draw just a short uh, horizontal line, and you have your top bars modeled. Okay. And then after you have that, select the rebar, select the topmost rebar, select it, and change its comment to top one. All right. And then select the second bar from the top, change the comments to top two, and apply, and you are good to go. So that's how easy it is to model rebar for rebar in Revit. Okay, and then if you'd like to see this in 3D, I'll show you something new at this point. So we are going to follow what we did earlier. I'm going to duplicate this, duplicate with detailing. Okay. So after I do that, I'm going to go to this arrow over here, and I'm going to orient it to a view, section view, and I'm going to select combined footing 2. And it's going to bring my combined footing there. Then after this has been brought, this section box usually has these clips, so you can extend it so that you can see more items. So let me see what we are working with. I think it should be around there. Let me see. So just move around, be able to just do this correctly. No hurry. And then after you have something of that sort, just select the walls, hide them in view. The walls, you can hide them by category so that you hide most of them. But for the foundations, don't hide them by category. Just select them. Just select them one by one. Select the street foundations one by one, and then right click, hide them in view by elements. You can also select these two columns here and hide them in view by, sorry, I just closed that. Where was I? Okay, just select them and then right click and hide them in view by elements, and you're good to go. Now you have a 3D view that is purposely for this, combined footing only. Then at this point, you can select, just place your cursor here, move it around, or use the tab key to cycle through options until one of the rebars has been highlighted. Then once you have rebars highlighted, left click on them, then right click to select all rebar in host. Okay. So once you select all rebar in host, I want you to go to the properties tab, and then under graphics, click on edit. So under graphics, you have view visibility, click on edit, and then this is what affects the visibility states of your rebar. So we want to view them unobscured. We want to view them unobscured. So in this footing one, copy one, just check it and click on OK. And now you can see your rebars in 3D there. Okay. So you can see your rebars really, really well. You can see how your detail is coming up even before you go to site. Okay. And the beauty of this is you can transfer this to paper and print it as well if you need that extra detail. And then you can always okay. You can make this footing a bit more transparent. So you can select this footing, right click on it, go to override graphics in view by elements, and then you can increase its transparency to around 60. Anything about 60 is sufficient enough, and click on OK. That's if you want now to view these better. Okay, so I'll change this to fine. So once it's in fine and detailed, you can now see the rebars pretty well in 3D and how they interact with each other. Okay, so that's how you do it, and I hope you're going to be able to proceed with it. So we are going to issue the deliverable later on, and I hope you're going to be able to work on it. So so that's one of the things I wanted to show you. And then there's one thing I would want to show you as well. So I hope you remember that is view depth affects how items are visualized. So if if you are to increase the view depth, you past this outer edge of the footing. Remember these rebars have return legs, or they have that 90-degree bend on this edge. So if this view depth goes beyond that point, you are going to view those bends. So if at this point you are going to go to the footing 2 detail, is that that's the footing 3. If you're to go to the footing 3, you're going to see these bend details. It confuses a lot of participants earlier on. So I'd like you to at least get a grasp of it. So if you find yourself with such a detail where the return legs, where these bends are seen, just go to your top of foundation, select the view depth, select the section, and then reduce the view depth. And after you do that, it now appears much better. Okay, and then you can just mirror this so that you have a good looking detail there, and that's how you do it. So we are going to issue the deliverable, and this is what I want you to do. I want you to open the sorry, let me open it now. I want you to open the combined details that we shared with you. So let me open mine now. I want you to open the combined details that we opened with you. So you have already, at this point, you've already created the foundation layouts. You've already created the foundation layouts. Okay. At this point, you've already created the foundation layouts. You know which footing is footing 1, which footing is footing 2, footing 3, footing 4, based on their dimensions. You also know the combined footings and the lift core footings based on their dimension. So what I want you to do is to model rebar for those foundations. So you're going to do one for each type. So you're going to do one for one. You're going to model rebar for one footing 1, for one footing type 2 of for one footing 2, for one footing 3, for these combined footing here, for these combined footing here, and for the lift core footing as well. All right. So that's what you're going to do. And this is where you're going to be getting the details. They have been labeled clearly over here. So you can be able to see footing 1. These are the details. It has 10 to 12 bars spaced at 200 millimeters. So you don't have to constrain yourself with a number. Just ensure that the bar diameter is correct and the spacing is correct, as well as the comments. And then do the same for these ones. For example, you can see the combined footing. So create a section for the combined footing, and you can be able to read them from this section over here. If you have any challenges being able to read this, please reach out to your captains, reach out to us, and we will assist you. All right. So it is approaching 10 p.m. and I would not want to keep you further or beyond this point. So I'll thank you. I'll thank all of you for showing up, and please continue working on the project so that we can be able to learn and grow together. So thank you for attending this session, and see you in the next one.